Hi, my name is Jason Ward. This is the Programming with Data Coursework 2 presentation. The objectives of the presentation are: 1, demonstrate some of the functions of the ADA packages, and then try and establish a profile from the dataset using those functions. Packages we're using today are Correlation Funnel. This is essentially a one function package, but it is actually very powerful. And Explore, which is completely different, actually has 46 separate functions, which we'll only be using a smattering of those here today. The data set we're using is the Bank Marketing Dataset. This is the result of a telemarketing campaign conducted between 2008 and 2013 by a Portuguese bank, the aim of which was to sell a term deposit product, which is essentially a savings product. So first of all, quickly open up our studio, load up the script file. This has all the code in from the report. We'll only again be using a smattering of that today. First thing we do is set our working directory here. As we can see, install the packages and call the libraries. We're also using tidyverse within this as well. We may use some of the functions from there. Next, we're just going to import the CSV file, which we've done here. Store that in bank data. Quickly view the head of that. We can see it's loaded, we can see all the variables, and we can see the first 5 or 6 observations within. So we're ready to. So first of all, we're going to use the report function here from the Explore package. It's a very handy function, this, especially if you don't know where to start, because it gives you an overall view of the data set. You'll see here, we're applying it to bank data. It's requesting an output file and an output directory because it actually creates an HTML report of the entire data set. So running that, we see we create an output BD report HTML. So go to the working directory, select that, and this is the output that we get. And you see there's lots of information here, lots of graphs and so forth. And this changes depending on the data set that you apply it to. What we're interested in is this section here, which just gives us a quick overview of the data. We can see we've got 41,000 observations, 21 variables. All the variables are named here. Then obviously the counts across here, type, unique values, min, max, mean. Particularly interested in this last variable, Y. This is the variable that records the outcome of the campaign, i.e. did the customer buy the product or not. Just to double check that, we can quickly run again from Explore describe on bank data, selecting variable Y. We can say it's a character variable, 2 unique values, no and yes. No's much higher rate of no's than yeses. What I have done, I've renamed that variable because I didn't like it being just called Y, so I've renamed it to term dep, represent term deposit. Again, quickly describe, check it's done, and there it's now called term deposit. So that's an overview of the data set, and the key variable that we'll be using is have they bought the term deposit. So moving on. The data set has 21 variables as discussed. For the purpose of this presentation, we're just going to look at the demographic data, not the customer contact and socioeconomic. In the report itself, we do go through in a lot more detail all of these other areas, but we're going to split it out. So we're just looking at demographic data really. We have renamed a number of the variables as well here. I didn't like how they were. I've renamed them things which I think are just more self-explanatory in that line of code there. And then we split the data out into the 3 subsets. You can see here, demo hist, we've selected from bank data, term deposit, then all these variables. We've done the same with contact hist and socioeconomic. Again, we'll not be doing those in this presentation though. So we now have a data file called demo hist, which is the main one we're going to be using. So first thing we're going to try and do is make a correlation funnel. This is from the correlation funnel package, surprisingly enough. So first of all, there's our demo hist. We can see it's 41,000 observations with 8 variables. And the first thing we're going to do is run the binarize function from correlation funnel. So you can see here, we've run binarize demo hist and stored the result in B demo hist. So what's that done? Well, first, if we look here, we've now got the same number of observations, but we've got 39 variables, not 8. So running glimpse on this to have a quick look gives us this output. We can kind of see what it's done here. It's split all the data into binary bins. So we can see now, instead of having just term deposit, we've got 2 bins now. Term deposit, no, term deposit, yes. So if they've said yes, they'll get a 1 in the yes bin. If they've said no, they'll get a 1 in the no bin. Again, if you look at job, it's split into all the unique values. So I don't know, 8 or 9 there. In the case of numeric variables, it automatically, the default is set to 4 bins. That can be changed, but we've left as it on 4. As you can see, it's split age range in 4 distinct bins up to 32, 32, 38, 38, 47, 47 and above. We'll look at that in more detail later. So we now have a binarized file of all the data. So the next step we're going to take is this. We're going to run correlate, which is the second function within the package. So as you see, we've got correlate on the binary data, and we're now going to target term deposit yes. So basically customers who said yes to the product. We store that in C demo cast, and then just quickly running ahead on that. What it's done, it's created a file, a table of all the correlations between every bin and whether the customer said yes or not. And what it does, it sorts it in descending order. So the highest correlations, both positive and negative, come to the top. So all these things at the top are the things that correlate best with a customer saying yes. That's useful within itself, but this is then used to create the correlation funnel in the next step. So moving on, we now run this line of code, plot correlation funnel. On the correlated data files, see demo cast, we set the limits to minus 0.1 to 0.1 because the highest correlation was 0.0993. So it just makes the funnel look a bit better if you can set the limits on outset. What this does, it now creates this, which if we enlarge, we can see we've created this plot. Now we'll see it's in the shape of a funnel. So what's happening here is the things at the top of the funnel are the things that correlate the best, both positively and negatively. So we can see here students and retired as a job description correlate positively with the outcome being yes. So these people are saying yes. Blue collar workers correlate the highest negatively, so these definitely are saying no to the product. Down the bottom are the things that don't correlate at all. So we can now see various different things within the data and get a good picture and start getting a profile of the type of people that would say yes. So we've got students, retired, single, university degree, all positive correlations on this side. We see here again the age range split into its 4 bins. And you see according to this, up to 32-year-olds correlate well, and then over 47-year-olds correlate well, whereas the mid-rangers correlate negatively. We'll look at that in more detail next to get a sort of more accurate picture using Explore. But this is correlation funnel, and very quickly you can start getting a good overview of your data and start spotting the things that are correlating well within it. And, very quick to actually get to this stage. So moving on, we now go to the Explore package, and we're going to use Explore and Explore All from there. As mentioned before, we're going to look first at the age ranges because the age in bins is probably not accurate enough. So what we're going to do is going to use Explore on the demo case data set. We're going to look at age and target term deposit. And what that does, it creates this graph here, and this gives a more fluid range of where the tipping points, if you like, are between customers more likely to say yes and less likely to say yes. So we can see here the tipping point is probably around up to the age of 33. We're getting a high proportion in the yes group or below the age of 33, and then over the age of 57. So this just gives us a more defined point rather than just using the quartile way of binning that correlation funnel did. So now we can take that a step further by looking at each different age group and trying to get a profile within there, because although the correlation funnel did that for us, it did pick out, say, retired as being a good correlation, but essentially if you're under 34 you're probably unlikely to be retired. So what we've done here is first of all select from Demog Hist that all the data where the age range is less than 34 and store that now in Demog LT34 less than 34, and then using Explore All on Demog LT34 the term deposit, and we're just going to look at job, marital status and education and target term deposit. And what that does, it produces this graph here, which we enlarge, we get a better view. So we can now, this is the under 34s, and we can see the job roles that are more likely to say yes, or were more likely to say yes. So we're looking at unemployed, students and admin, and as you can see, retired doesn't feature, surprisingly, under 34s. Single still features highly, and university degree educated features highly. So we're starting now to get a picture of the type of people we can target. So in the under 34 age range, these are all factors which correlate best. Now looking at the over 57, we just run the same line of code again, but we specify over 57s. And this gives us this output. So if you can see, the demographics now changed significantly. So in the job role, retired is predominant, surprisingly enough, in the over 57s. There's no particular marital status that seems to win out. Divorced slightly better, but only slightly. And then in education, not university educated this time, but basic year 4 education, the kind of lowest level above illiterate, in the over 57 age group. So we're getting a different picture for the over 57s. Just for completeness, look at the mid-range age, and we see that unemployed, technician, management, admin all score well in job roles. Single again is slightly better on marital status, and we're back to university degree educated seems to be the predominant factor in customers saying yes. So bringing this all together, we can then, just with a few lines of code there, we've demonstrated we can get a basic demographic profile, which potentially the bank could use to target customers in future campaigns that are potentially more likely to say yes. So we can say less than 34-year-olds, maybe students and administrators, single, university degree level educated, over 57 group retired, basic year 4 education, and the between group technicians, management, administration, single and university degree. So hopefully that's demonstrated the usefulness of these packages. We've been able to get some answers very, very quickly. Obviously, it's quite basic. We go into far more detail in the actual report, but hopefully we've demonstrated the usefulness of some of these packages. Okay, thank you very much. Bye.